do that at some point. But I thought it'd be relevant to look at this of if you have an encounter with police, for example, or other law enforcement officials. This data set is trying to be as impartial as comprehensive as possible about how that happens, who it happens to, who's doing it, how you die, etc. These other things. It's essentially a big spreadsheet or CSV file, whatever you want to say. They have people's names, which I think is unnecessary. That's not helpful. A bunch of ages, people's race, because that's unfortunately matters a lot. This goes back to 2000. We have 20 years of unfortunate data. 21, I guess. 20 and a half. And like the state and these other things. And like the exact lat long and where it happened, which I don't think is super relevant. My goal is to look at how things vary by state in terms of absolute counts, conveniently, counts by year. They don't have every year, but they have near population, so you might impute between these things. And possibly by what they had, type of death, cause of death, I should say. And there's a lot of like vehicles, yes, cause of death, vehicle, people run over apparently is very common. I didn't realize that. Gunshot. These other kinds of taser things. Tasered, slightly different there. We kind of want to explore this data set and see what's going on. And this data set, I will say, is extremely up to date. I downloaded it just today, and it's got entries from June 1st, yesterday. So, very, very up to date. And I just want to see what we have here. This is also going to be a little bit of like, how do we plot things on a map? So that's going to be a lot of the challenge that we go through. But it's fatalencounters.org if you want to check it out. And of course, I'm looking up, how do I make a choropleth, which is like a heat map of a map. A heat map of like a geographical area. How am I going to do this in Python? There's a couple different ways you can do it, but we'll get to there when we get to there. That's not what I wanted. Here we go. Right now, I just want to start getting that data and taking a look. I don't have a specific goal in mind other than what I've already described. We're probably not going to do any machine learning. We're not going to try to model anything. I highly doubt. It's more about building a visualization and understanding the data today. So my file is called fatal.xlsx. I chose to download it as an Excel file just in case I wanted to do some wacky things. And I'm pretty sure we could do that. pd.read Excel. Is that exactly? No? What? You be kidding me. Read Excel proper even. Fancy. Read Excel D file. That's what we're going to do. There are a couple sheets because there's that what? XLRD for Excel support? You know, screw it. I'm not doing that. I'm gonna download it as something else. Download as CSV. There we go. Perfect. Yeah, I ain't doing that. Ain't doing that one bit. What I'm gonna do, move the CSV to my proj. I'm just gonna do that. Make my life a little bit simpler. There's not so many data points in here. 26,000. I say there's not so many. That's a lot. Like, that's a lot of people, right? So I don't want to come off the wrong way. In terms of a data science perspective, that's a good number of data points, but it's not a ton. You're not going to be able to build crazy complex models with this. But that's okay. That's not the goal. Fatal.csv. Okay, so these are all the headers, all the subject names, all this other stuff. And items below this row have not been fact-checked. Well, that row is not in here. I actually don't want that in here, because that's not a row. Alright, and the rest of these are all good. We don't have the second page. I guess I can download that separately. There we go. Download as CSV. Perfect. Realistically, we're going to want to get yearly census data for all these states. But that's okay. Alright, I don't really need that open. And let's move that as well. Fatal. I guess I was playing Fallout earlier. CSV. Abbreviation and populations. Yes. States.csv. Perfect. Okay. get this, get that. It's, you encounter weird problems, just find ways to work around them. So you got a large number of columns, like the specific ID for that row, the subject's name, if available, it's not always available. Their age, all this other stuff, their gender. Probably is listed on their driver's license or other ID. Something like that. Internal use not for analysis. That's interesting. That they have something that claims that information. So you could look at, for example, looks like date year is an option. And I'm going to do this like this since they're all weird strings and not fancy column names. Oh yes, I want to pretend it's a dictionary, even though it's not, it's a pandas data frame. So you get all these 2020s, this ought to be 21 things. Oh, interesting. Ref value. So there's going to be some bad data in here. We'll have to clean up this data a little bit. This is always the case in any fresh, hot data set you've got. Unless it's a data set from some standardized competition, you're going to have to clean it. That is always how it is. But the good news is we don't have anything that's like 2, 0, 1. It's all 4-digit, except for these bad values. So we will have to do some cleaning, but I do want to get this choropleth business. I want to see what is the right way to do that. And one tool I've seen, it's called Folium, and I've dabbled in it. It's a way to make a nice little interactive map, but it's designed to work in IPython notebooks, which is a bit of a drag, because I like to work in IPython proper. So some people have been trying to implement various workarounds to this. It looks like there's certain things that haven't been touched in a couple of years, though, which is unfortunate. Yes. Force pushed. That's funny. There's a couple different ways to do this. I need to see, do I have Folium? I do not. Okay. Pip install, sudo, oh, yeah. Sudo pip install, yes, from formerly Poutine. Folium. Let's install this. See how we go here. There might be some other things we have to install along with this. It does some weird JavaScript stuff to make this interactive in a way. I don't really need that, but I mean, it's kind of nice. And if that's not going to play nice, then we'll just, I'll use CartoPy or something. But as you can see, there's a bit more stuff you have to do to make that work, when really it's just like, I want to have boxes that are drawn in this particular way and colored within those boxes. I don't feel like that's insanely difficult, but you never know. Some things get to be a little bit pain. It says the ugly GeoPandas. I think I've dabbled in GeoPandas too. Successfully installed, whatever. Great. Import Folium. Cool. Now we have Folium. I want to get my state data as well. States.csv and states equals pd.read csv s file. Make sure we get that. It helps if I define the file. Ooh. Didn't I move that in? Hang on. What just... Oh. I'm a dummy. I didn't put it in the actual project directory. That helps. Much better. And now you have this data frame as well, which has different columns, has the state's population in various years, things like that. So we'll be able to impute that and create a full matrix for every state. Actually, I have an important question. How many abbreviations are there? Abbreviation. Because, like, nominally this is just US. Are there actually 50? Or are there more? 51. So here's the question. Where state is extra in here? It's probably like an other or something. I have to look at this list, like I'm an American, I have to know like which one of these is not a state, but you know, you casually glance at it, they all look like states. But one of them is not. You know, Wisconsin, Washington, West Virginia, Wyoming, Vermont, Virginia, Utah, Texas, Tennessee, South Dakota, South Carolina, Rhode Island, Pennsylvania, Oregon, Oklahoma, Ohio, New York, Nevada, New Mexico, New Jersey, New Hampshire, NE, Nebraska, ND, North Dakota, North Carolina, Montana, Missouri. Hang on. What is MO? If MT is Montana. Mississippi, Missouri. Okay. Minnesota. Michigan, Maine, Maryland, Massachusetts, Louisiana, Kentucky, Kansas, Indiana, Illinois, Idaho, Iowa, Hawaii, Georgia, Florida, Delaware. Oh, DC. Duh. Washington, D.C. That's our 51st location. All right, good. That all makes sense. I want to get this mapping business working a little bit. But we can also just like try to rip out, like do a count by state, I guess. Is there a count actually? There is not. Okay, that's fine, that's fine. I thought there might have been, but I suppose not. S equals, yeah, let's just make that right now. States dot abbreviation. Abbreviation. So that gives us that set exactly. And then for S in S, we will be looking at data where the Jesus location of death state. Right. So let's take a look at that column right now. Location of death state. How many things do we have here? How long is this? 51. Oh my goodness. Lucky day. DC's in the list. Okay. Okay, this is actually good news. There's no unknowns listed here. Perhaps they just cleared those out, or the state is usually pretty well defined. So that is actually good. Let me grab this. It's a bit of a mouthful there. Bring that back. So the data of this, where that is equal to S, I want to pull out that row. Actually, no, I don't even need to pull out the row. I don't need other information for that. What I want is, in fact, I don't want a set. I want a list of a set. And I want it to be sorted. Can I sort a set? Sorted S? Yes, okay, cool. Let's just do that. I just want a list so I know exactly where each index is. SD for state deaths. Start this out at zeros. That is going to be zeros of length of S. And what we're going to say is that SD of S, no, S dot index, no, we'll just say I here. This, and we'll just slap an enumerate around this. Enumerate. Right, there we go. And I want to count up how many times this happens. Okay, I think that's what I want. So now this should be a listing of all the state deaths. And we can import matplotlib.pyplot, splt, plt.ion. What I really want is like a bar. I don't really care where things are positioned. A sequence of scalars. Sequence of scalars. That's really not what I want. Coordinates of the x bars. Height. Sequence of scalars of the bars. Can I? Maybe there's a seaborn way to do this. Matplotlib bar chart label. Grouped bar chart with labels. That's sort of what I want. G1, G2, G3, G4. How do you do this nonsense? Like, you have to manually create it, essentially. Is that correct? Yes. You're manually creating the rectangles here. Even though you've got labels, men's, women's. Like, I want, like, labels and men's. It's not that complicated. Oh, boy. Let's do Seaborn. That's a matplotlib derivative. But it makes a lot of things a whole lot easier. Unless you want explicit control over things, yes, that's pretty much what you want. See how much easier this is? Like, import Seaborn. I'm not even going to set the style or this other nonsense. Bar plot. What are the labels? How big are the things? Oh no. What are the labels? Oh, I see. You pass in like your data frame, your dictionary, whatever. We're going to import Seaborn. Import Seaborn as SNS. Do I have it? I thought I did. Yeah, nice. Cool, cool, cool. All right, import Seaborn as SNS. I like that. And then I want to say SNS dot, what is it, bar plot? Oh, nope, that's not what I want. SNS dot bar plot. How does this work exactly? Can I put in actual data here? Vectors, to pass directly to X and Y. Is NumPy or Python objects, pandas objects are preferable because blah, 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 blah. Names of variables in here. Optional infos are probably along with examples for interpretation. Do you have some examples in here? Are these all like labeled with, this is my one problem with. Like, I just want to have my data, I don't have to put it in a data frame. I want to be able to just plot. Can I do that? If I say, I don't know, A, B. I say X equals AB, in fact. Y equals 10, 20. Is that a thing you can do, bar plot? That is. Okay, that's perfect. Then that's exactly what I want. I don't need fancy labels sort of thing. We're just exploring the data. Perfect. So what are my labels? My labels are the states. What are the numbers? That array. Hashable type set. What? Oh. Shouldn't have been a set. There we go. And now you can see this. There we go. And they're even colored as you go along, I think. The color ideally would be like by the height. But that's not a big deal right now. And you might think, oh, you know, California and Texas, except this should be divided by the state's population over time. So actually, let's look at that just briefly. SDR. Let's say pops, and this is again going to be per state. But let's just take an average of the four. We could take an average of the four entries they have in this states thing. States.col. Population 2010, 2005, 2000, 2015 estimate. That's fine. So what I want is states. This is gonna get a little bit goofy here. Population of this, you know, plus, in fact, oh, and this might not even be in the same. Oh boy, oh boy, oh boy. What I want is to say states average pop. Yes, is going to equal to this nonsense. Okay, that is what I need. And let's take a mean of, actually, does pandas have like a mean built in? It'd be nice if it did. Merge, melt, merge, merge. No, okay. No, didn't think so. I mean, there's no reason it would have that. And let's do these other ones as well then. Do this, that, and all this other nonsense. Get back over here. There we go. And this one will be for 2000. This one is 2005. This is 2015. And that one is estimated. Estimated. Just like that. Okay. That should be good. This will add a new column into our data array. Population 2015 estimated. All right, what is it called then? Population 2015 est. That's what I get. That's what I get. There we go. 2005, 2010, 2000. Okay. Give that a whirl here. Yes. Unsupported data types for int and string. Interesting. One of these is not D-type int64. You what? Oh, come on. That's a crime. That's a crime right there, pal. That you're... Oh. Why? Why are they stored differently? Okay, so we're going to have to fix those. Because this is some kind of... What is it? A string? Or is it just arbitrary objects? Oh my goodness. What if I turn it into an array? What happens? Go! 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 Jeez, oh boy. Let's do a quick figure out how to fix that nonsense. Oh my goodness. Convert comma separated number. Yeah, to int. Is there a built-in way to do this? Oh, just replace all those. Yeah, that's true. That's a smart, a quick thing to do. Okay, we will do that then. So first, fix the populations. Fix the population values. These are the kinds of things that you always have to deal with. So, states of, and this is going to be, what's the ones with the problems? 2000 and 2015. Like, if it was just 2000, I would understand, but there's multiple of them, which I find strange. We're just going to fix it. We're going to overwrite. I don't want that other one here at all, because that's just wrong in so many ways. I will turn this into an array, and what we're going to do is take the value, the population, and we will replace all instances of comma with nothing for p in this thing. There we go. Except, we have to do one more thing. Convert it into an integer. Let's see how this works. All right, and then take a look at this. Good. Now we're dealing with integers. Life is good. Now we do the same thing for 2015 est. And of course, we need to fix this here as well. Otherwise, we're going to lose it. I'm going to be very, very upset. Okay. Now then, just verify this is what we think it is. Cool. Now we can compute the average population. What a mess. What a mess. I hope to have some kind of map at the end of this, but that's a mess. That is not right. Nope, that's not right at all. That's super duper wrong. I'm pretty sure 6 million people is not the average population of every single state. No. No. Because I did this along the incorrect axis. Takes an axis. I should have done this along axis 0, 1, 2. I'm not sure here. Axis along which the means are computed. Means the flattened array. So, go over here. Axis equals 1. Axis equals 0. Excuse me. Right, this is the first axis across these 4 values. That was the problem. Let's try that again. You know, the average population across all states and all years is 6 million. That's good to know, but not what I was interested in computing. Hey, there we go. Grr. And then if I, of course, just say plot.plot of this. Yeah, cool. Actually, I don't even want to plot. I want to bar plot that. So this is our put this down here. Yes. Cool. And surprise, surprise, California and Texas are, I didn't pull out the right thing. There we go. All right, surprise, surprise. California, Texas, New Mexico. New Mexico? What? Hang on. There's something not right here. I do not believe New Mexico is that populous of a state. For real? Average pop, 2 million. What? That does not seem right to me. Unless NM is a different state and I'm losing my mind. Yeah. Let me go back to this thing. NM. New Mexico. It's about 2 million people. New York, 18 to 19 million. What is going on here? What is going on? Like, New York should be huge, should be off the chart. But there's nothing here. Okay. There's definitely something wrong. And we need to figure out what went wrong. Let's take a look at some of our data. Can I? I don't think I can do. What is it? Abbreviation? Yeah, or just name, whatever. Name's fine. I don't think you can do that. Yeah, but I think I can pass in a list of things. In fact, I want to pass name in first. Get rid of that stuff. I think you can do this. Yeah. Okay. New York. What? What? Something went wackadoodle here. Yeah, New York's way... You're telling me 19 million. Ohio is only 11 million? Texas is... Something went way wacky here. Way wacky. Yeah, something's very not right here. New York. That looks correct, actually. That value is approximately correct. And New Mexico, yeah, like 2 million. Are my labels just insane? Am I looking at the wrong place? Maybe that's... Let's try this one more time. Are these in a different order than I thought they were? Is that the problem? That could in fact be the problem. Come on. This isn't that hard. Lot already. There it goes. Alright, yeah, this has to just... It's munged up my labels here. Which is super bad. Super duper bad. Okay. Well, that's good to know. That this is not the... Why would they not be in sorted order? That's what happened. That's what's happened here. States of... Oh, they're in name sorted order, I bet. Not in abbreviation sorted order. Those are not necessarily the same thing. Like Arizona comes before Arkansas. Okay. Okay. That I will get behind. Yes. So when I call sorted, I should fix this and sort based on the names. Turn new list containing all items. Custom key function be assigned to customize the sort order. Yes, that is what I want. Thank you. So key equals lambda x. Yes, you're only given that object. So I want to say states. Ugh. Yeah, sort one list by another is always a thing I want to do, and I swear I have a function to do this. Actually, is this in Big Yellow Duck? This is BYD. Ah, never mind. Nope. Do I have a library? No. Okay. Thought I had my own personal library somewhere, where you sort one list by another list. Ugh. I guess I could arg sort it, right? What are the indices that would sort an array? And if I did states dot name, yeah, okay, that's what we want then. There's exactly 51. I'm not doing any of this nonsense then. We'll do numpy.arg sort of states.name. Capital N name. This gives you a bunch of indices, which we will use to reorient states.abbreviation. Abbreviation. In precisely this order. S equals this. So they will be in state order, not in abbreviation order. Yeah, it's a mild irritation. Yes, okay, this is a little more, it's mostly sorted that way. And now you see, okay, yes, New Mexico, where's New Mexico? Not that high, New York. I'm actually surprised New York's not higher. That's, but you know, we'll look at the populations and we'll find out. Okay, let's redo this just to make sure I did this all correctly. Int object has no attribute replaced, right? Because I've already fixed it. Don't even worry about it. It's taken care of. Okay, now, yes. New York population, about 20 million. California, 3.5 million. Texas, 2.5 million. So on and so forth. You can find your state here. That's not too bad. The average of all these is like 6 million or something. Which should be about right here. Because there's a number of states that are really tiny. Really, really tiny. Oh my goodness. In terms of population. Now then, so these sort of fatal encounter, the state death rate here is always the thing I want to look at. A lot of things, you just get exact numbers, but obviously if there's more people, that's just more people that to do killing, to do the dying. You should almost always be looking at least a rate when you're considering population. Otherwise, you're just going to look at a population density map, and it's not going to be very interesting. So this is going to be whatever our actual count is divided by this population. And then we'll look at that as well. And then we'll worry about trying to put this in a map. If I make some simple bar charts, that's something at least. Okay, now you get a very different picture, right? Suddenly, California, you see has, 125 deaths over this period, over this whole period of 20 years, per million people population, right? 125 E6. New Mexico actually does have a somewhat higher rate. Texas, somewhat lower. A lot of these, like Connecticut, much lower. Massachusetts, MA, I can always get this mixed up. And there's a mix. New York, relatively low, actually. So that's kind of interesting. But I find it interesting that places as different as like Arkansas and California have very similar rates, according to this data set, right? According to this data set is always the key thing here. Texas, not appreciably different. There are definitely differences. Like, I'm really surprised that New York is this low. It could just be there's that many people in New York City. But, yeah, that's interesting. And I would have thought some of these to be with the square population, but I don't know. Maybe they've implemented better tracking. Or did I screw up one of these columns? That is the other possibility. Like, did that happen? Like, this is S, NM, NY. Hang on. I want to make sure, NM, NY, AR, AZAR. Yeah, okay, that's how you know it's nominally correct, AZAR. Yes. Let me plot this again, actually. Because New Mexico should be almost nothing, because there's just not that many people there. There's actually a lot relative in here. New York is still really low. Huh. That's surprising. That makes me wonder, like, is the New York data in there? Is it harder to get New York data? For now, though, we have this plot. I want to try plotting this as an actual map. Don't want to do the GeoPandas business. I don't really want to do CardinalPie business. I don't really want to do that. We want to try this Folium stuff. In good gravy, what is going on here? Open geo... what? Just json.load.open geo... Where is this path, man? Did you already make that? It's like these things. They're not little self-contained. Geo... path. Okay, so that's what states this person is loading. They're loading up a bunch of Brazilian states. US states geo JSON. That's what I want. Should be able to just grab this. Blah 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 blah. Why would I? Good gravy. Yeah, just download this file. Just give me the raw, and then I'm gonna download. Problem solved. Look at that. usstates.geo.json. How convenient. Let us then move that from downloads us.states into this current directory. Okay, and then that is that's a geopath. Come back over here. Okay, I don't really want to futz around with threshold scale that much. We'll go ahead and copy this. And we need to import our JSON as well, just to get that information. It's pretty normal. Geopath then. Geopath equals /us-states.json. Should be fine. Cool. Geostring. So you get the whole string as a bunch of JSON, whatever. I don't know why we loaded it and then we dumped it again when we could have just read it, I guess. Maybe not. I find that strange. You need to make your map. And there's ways you can connect to like map servers and all this other stuff so you can actually get all the like aerial imagery and stuff, but I'm not gonna worry about that. Mapbox bright. Location. I don't know. What is an actual location here? -140? Okay, let's do that. Just somewhere in the United States. Like there's a place in like Oklahoma or something that's the nominal center of the country that if you didn't, in Google Maps for a long time, if you didn't have the right address for something, it would just send you there. And so the poor people who lived there kept getting all kinds of visits and calls, but people were like, well, no, we put it in the maps, I said to go here. Well, no, it was just an empty place. Let's make this map. Okay, I didn't turn off my auto indent. Oh my gosh. Maybe that's causing my problem. And they do this nonsense. Right? Oh, jeez, oh man. Set. Turn on a paste. Ah, come on. There we go. We're going to fix this up a little bit. That's like, what are we pasting on? This is like the data frame. map.a.geojson. Really? Map A? What can I do with map A? What? That's an aggravation. We just don't get a thing? How recent is this? 2015. Choropleth folium. Let's just find a proper example. Quick start. Perfect. Python visualization, folium. You can look at the map. All this other nonsense. Basic map. Yada 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 yada. You can save it to a file. Oh, cool. Map. Yes. We don't want to add markers. I want to do choropleth. There we go. Oh, folium.choropleth is the proper business. It's almost exactly what we're going to do. We're doing US states, all this other stuff. And you add it to the map. That's right. This is feeling familiar to me. All right, delete all that nonsense. GeoData equals GeoString. This data is not exactly what we want anymore. I guess what we can do is we can say states of the rate, right, is equal to SDR, and states of the count is equal to SD. And then we can, come on, then we can actually do this down here, where we'll put in state or like name. Oh, I guess, to make this work right, you have to, like, your JSON has to look correct, right? Properties, name, Wyoming. Column, state, and unemployment. Yeah, okay. So state should be name, and this is going to be the, like, rate. That's what we're going to do. And there's some opacity delay and some other stuff. Fatal encounters with police rate. Encounters with police. It's not a percentage. And this gets added to map A. Map A. But of course I haven't shown anything yet. State data is not defined. Well, that's true, because it's called states. Okay, so that made it, but like it's not being shown anywhere, which is, you know, a bit of a drag. 48 negative 102. Okay, let me fix this. All right, in fact, let me del map A. There we go. Okay, now we've made that. Now the catch is, how do we do something like this? How do we show it in zip browser? That's what I want. Collected all the pixels here. It's like someone's clearly working on this. Otherwise, you got to do this stuff. Import HTML and display. What? I don't want to display an IPython notebook, though, dude. Build map doesn't exist in Core. Following word work for me. Again, I don't want it to work in a notebook. I just want straight IPython. I want to open up a browser. This, again, has not been touched in a while. Been thinking about it, going back and forth, and then nothing. Does it exist? Does m dot... What kind of things does m have? What kind of things does map A have? Well, save might actually do. Okay, let's try that actually. Map.html. Just do that, and then I will come over here. And what will we do? Proj fatal. There we go. And we'll look over here at map.html. That did not seem to work. Like, we have a map, right? That's good. But there are no colors here. Clearly, it's not really interactive. But these numbers are all way too small. So what is the problem? Is it like the tiles that are bad? Is it the fill color, the opacity? Like all kinds of things that, like, if we had an actual IPython notebook, we could very quickly see what the heck the problem is. As it stands right now, we gotta futz around with this and see what the issue is. Oh, boolean.layerControl.add2. Yeah, that's probably something we want to do. Let's do that. Map A. Okay. And then let's say map.a.save of map.html. Do that. Come back here, reload. Yeah, and it's still not wanting to show. Alright, well let's do something dumb. Let's make random data. Garbage. An easier thing to do. I'm going to say that states garbage equals numpy.random.randint, I don't know, between 0 and 100, just to make my life simple. Let me remember how this works. The low, the high, the size, yeah. Maybe 51 numbers. In fact, I won't even guess. Length of S is what we'll do. And then, what I'm going to do here is do this stuff. I'm just going to make this a function. Def make map. Right? No, I don't want that to like set the specific columns. You know, yeah, okay. We're gonna have the data frame and the column. That is the only things we're gonna be doing with this nonsense. Because this, where's the data? In fact, we'll even make it easier on myself. The states and the column is gonna be, in this case, garbage. Yeah. So here, it's always going to be name. This is going to be column. This is going to be df. Should be good. Got that. Now I can make a map. And yeah, it's not displaying the colors, which is annoying. Why not? Why not here? So like, are these colors super wrong? Line opacity, fill opacity, 0.9, key on feature.id. Is that the problem that's wrong? Feature.id. What are they keying off of? Around, I guess I don't have that. No. And this is why Folium, it kind of grinds my gears a bit. Like, it's a little bit of a pain to get working. Feature.id. Using this business, the same GeoJSON that I have. Yeah, this shouldn't be rocket science here. And actually, what I want to do something I almost never do, pull up an IPython notebook, just to check, because I'm losing my mind a little bit. Proj/fatal Jupyter notebook. Really? Wow. All right, maybe I won't be doing that. Could have sworn I had that. Could have sworn it. Oh boy, do I have CartoPy and other things? I know that can work. No, I don't. And CartoPy isn't really. Isn't really supported anymore, I believe. So that could be difficult. Matplotlib choropleth. Yeah, let's take a look at this thing. Yeah, I know what a choropleth is. You're using GeoPandas, which is not as Descartes. Maybe that's the new one. Yeah, 2019. So it's called Descartes now. Okay, I think that's the new name for CartoPy, which might be a little bit better. Mapdf.plot. That's actually not terrible. Comes with built-in polygons. Interesting, interesting. Here he's got a map of Indonesia. He's doing some stuff. Oh, what is this nonsense? Error command. Da, 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 da. Okay, fine, fine. Descartes. Let's give that a try. And if this blows up in our face, return back to this choropleth option and see what the heck's going on. Like, does saving the HTML not work, in fact? Here we go. Python, Folium, save map as image, as HTML, sure, one of these things. Save image, access map HTML without saving the file. I mean, that'd be ideal. Yeah, create map from that. CUDA capped? What? What is wrong with it? Oh, jeez. Like, this is clearly something you ought to be able to do. What is this? Sleep. Browser.webdriver. Browser. This is insane. Why would you do this to yourself? Open generate HTML with Chrome. Print it. Yeah, I mean, that should work. But it doesn't. Let's go back over here. Obviously, they're going to say, like, well, oh, jeez, get the horrible HTML. Yeesh. Yeesh, 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 yeesh. Yeah, let's actually try to go back to map. Yeah, let's come back here. I don't like to look at the source. Like, we're doing a whole lot of horrible things here. Like, is this information in here anywhere? That's what I want to know. Like, here's the GeoJSON. Great. So that all gets in there. Add to choropleth some stuff. Go through the GeoJSON. And then we got some colors here. Color map, D3.scale.threshold. Like, to me, this looks like a whole bunch of different colors. Different scaling. Those are the actual colors. Those are the numbers. Where are the numbers that I put in here, man? They're not in here. Why is that the case? We're running out of time to figure this out today, so we may be coming back to this next week. Alright, install Descartes. Alright, let's... Oh my gosh, it's like I gotta declare tab bankruptcy here. Don't have time to figure that... Oh, I wanted that one. Still want that one. Don't want that. Python, Descartes, quick start. Oh, which is exactly this, isn't it? Yeah. Merge and show the map. Merge df, merged.head, Okay, yes, this kind of thing is what we want. Edge color plot, .normalize. Oh my goodness, I don't want any of that nonsense. I don't care about that. Just want to see the map. Configure an axis for map. Where do you make the map? Where does that happen? Create map. Merge.plot. Okay, that, like, this is the only thing I care about. Like, on what axes to do it. Like, none of that. Just make a new axis. Just show me what it is. I'm not making a pretty end result picture here. Merged.plots. Merged has to include, like, the geometry of the thing. Oh, interesting. That's wild. That is absolutely wild. You gotta have GeoPandas do this. This is like a well-known text kind of string, I guess. Let me... What does Descartes look like? Descartes... Oh, well, import Descartes, man. Actually, is that really part of this? Descartes? No, don't bookmark this. Descartes to generate a matplotlib plot. Pandas data frames to next allowing to parse geospatial data. Wait, what? If you have a proper data frame. Hang on. GPD, GeoPandas can do this. Yes. GeoPandas. Yeah, okay. That's what I thought. That's what I thought. GeoPandas is doing the magic. Let's see if this works. If not, we're gonna probably call it there, and that's gonna be that. And we'll work more on the map next time. Maybe there's something I'm missing regarding Folium. Maybe, you know, it's really only for Jupyter Notebooks. Folium, yeah. Folium, open map in browser. That's really what you want. Yeah. But this clearly is not working correctly. This seems like it would work, but it doesn't. I don't know why the folium chloroplast is not working correctly. Like its name, not like, oh, its name's clearly the correct thing, right? Do I not want name here at all? Is that the thing? If I did this, what if I did that? That yellow me? Yeah, list index out of range. Yep. That's no go there. Name is indeed one of them. Unnamed 2. Great. Unnamed 7, unnamed 8. Oh boy. This is why I make bar charts for things. And try not to drive myself insane. But if I want this to work, like for the excess death, I want to do a similar kind of thing. You could try to like center them each in its exact correct location. Why? I just don't see why. Oh, now even less. That's interesting. Well, ain't that something? Yeah, but you're just not getting the numbers that we actually want. Key on feature.id. Maybe that's the part that's mixed up here. Core opleth. You're like, how is this working? Plot a GeoJSON overlay on a base map. Key on. Variable in the GeoJSON to bind data to. Must start with feature and be in JavaScript object implementation. Generally, features or properties that state name. Oh, so I probably want this really. I don't know why I would use ID here. Let's do this. That's probably really what I want. Given that we've got this geostring business. Feature.properties.regular name, I think. I think that's what we want. Let's try that. Hey, it's just a bad ID. Go figure. I have no data for Puerto Rico. I'm very sorry. That is empty. Okay, so we have something now. We have a map. We can zoom around in. We can see things. It'd be great if I could click this and get some information, but that's okay. These are random numbers that I generated. That's not what I actually want. So I want to make map with column equals, what did I say, right? Let's do that. Let's come back here. Boom. And what is going on? Wow, Washington. Right? Yeah, Seattle, Washington, Oregon. Way higher than you would expected. Alaska, also way higher. Sure enough, New Mexico, Oklahoma. These are probably related to their specific populations in those states. And obviously, we're not doing a hardcore statistical analysis of this yet. We might still do that. But that's, I say the populations, the way police forces interact with those populations is really what I should say. These states are dealing with different issues. It's not to say that these states are definitely wrong or right, other things. And again, New York, far lower than I would have expected. Wow. And this is per, yeah, this is the population, the number of deaths per person. So really, we probably want to say something like SDR times 1,000,000, because that's approximately what the rate of all those were. So if I say very quickly, rate, the kills, deaths per million, say, equals states of rates times 1E6. And then I come back and do this. DPM. Do that. Reload this. This is the same color map. Okay, but now it's per million residents of that state over 20 years. How many people died? How many people were killed in interaction with police in some way? I also like this as an actual, like if there's other things on this globe, that would show up here. Like this is actually where Alaska is. Oh, where's Hawaii? There it is. Sorry, sometimes it's hard to tell, like, what's a smudge on my screen and what's Hawaii? I'm very sorry, Hawaii. You're fine. You got your little 5 islands here. Yeah, But as far as like continental United States, this is that map that the ratio is like, what is going on in Seattle? Is Seattle just black actually? Or not Seattle, Oregon? Washington? I think that might just be black actually. Then that there's no information. Like, what is going on in Washington? These are all completely reasonable numbers. I don't understand why it's as goofy as it is. Is there something maybe misspelled somewhere? That's my suspicion, actually. Oh gosh, is this not in order? Wisconsin, West Virginia, Washington. What is the state's name? Washington State for... Come on. Oh, that explains that. That's not Washington's fault. This is some data we gotta clean that somebody did that bad things to. Bad things. This is why I want to use the abbreviation. Boy. Come back up here. States of... Yeah, we gotta fix that. Fix Washington State. Washington State. Like, that's one, like, I might just fix in the file itself. That grinds my gears. Washington State. What is this? Get out of here. Virginia State, no one cares. Okay, whatever, we got the map. That's the thing that matters. Be very careful how you use Folium. Other things probably work well too. This gives you a nice interactive map. You can zoom around. I'm sure there's ways to get feedback where you click on it, you can get some information. It's all JavaScript. There's DC a little bit higher, for example. These kind of maps can be deceptive though, because areas that are just huge, like Texas, New Mexico, California, Alaska, have sort of an outsized weight in your brain. There are ways to kind of correct this. There's some kind of cool things you can do. I don't know if we're going to get to that. I just thought it'd be relevant to look at this, and you can see some interesting information here. I'm not going to draw any conclusions because I'm just staring at this. I don't have a lot of background in this area, but I wanted to plot it and see what was going on. All right, that is all I have for tonight. We might look at this more next week, see some interesting things, but I guarantee if you just looked at that and you didn't plot the rate, you're going to see a lot less interesting things going on. Like a count suddenly looks like a map of population density again. So that is all I got. Thank you. See you next week. Stay safe in the data mines.